Example 7. Write out the form of the partial fraction decomposition of the function x cubed plus x squared plus 1 over x open x minus 1 close open x squared plus 1 close open x squared plus 1 close cubed. Sidebar: it would be extremely tedious to work out by hand the numerical values of the coefficients in example 7. Most computer algebra systems, however, can quickly find the numerical values very quickly. For instance, the maple command convert open f comma parfrac comma x close, or the Mathematica command apart open bracket f close bracket gives the following values: big A equals -1, big B equals 1/8, big C equals big D equals -1, big E equals 15/8, big F equals -1/8, big G equals big H equals big G equals big H equals 3/4, big I equals -1/2, big J equals 1/2. Back to the text solution. X cubed plus x squared plus 1 over x open x minus 1 close open x squared plus x plus 1 close open x squared plus 1 close cubed equals big A over x plus big B over x minus 1 plus big C x plus big D over x squared plus x plus 1 plus big E x plus big F over x squared plus 1 plus big G x plus big H over open x squared plus 1 close squared plus big I x plus big J over open x squared plus 1 close cubed. Example 8. Evaluate the integral 1 minus x plus 2x squared minus x cubed over x open x squared plus 1 close squared dx. Solution: the form of the partial fraction decomposition is 1 minus x plus 2x squared minus x cubed over x open x squared plus 1 close squared equals A over x, equals big A over x plus big B x plus big C over x squared plus 1 plus big D x plus big E over open x squared plus 1 close squared. Multiplying by x open x squared plus 1 close squared, we have negative x cubed plus 2x squared minus x plus 1 equals big A open x squared plus 1 close squared plus open big B x plus big C close x open x squared plus 1 close plus open big D x plus big E close x equals big A open x to the fourth power plus 2x squared plus 1 close plus big B open x to the fourth power plus x squared close plus big C open x cubed plus x close plus big D x squared plus big E x equals open big A plus big B close x to the fourth power plus big C x cubed plus open 2 big A plus big B plus big D close x squared plus open big C plus big E close x plus big A. If we equate coefficients, we get the system big A plus big B equals 0, big C equals -1, 2 big A plus big B plus big D equals 2, big C plus big E equals -1, big A equals 1. which has the solution big A equals 1, big B equals -1, big C equals -1, big D equals 1, and big E equals 0. Thus, the integral of 1 minus x plus 2x squared minus x cubed over x open x squared plus 1 close squared dx equals the integral of open 1 over x minus x plus 1 over x squared plus 1 plus x over open x squared plus 1 close squared close dx equals the integral of dx over x minus the integral of x over x squared plus 1 dx minus the integral of dx over x squared plus 1 plus the integral of x dx over open x squared plus 1 close squared. The natural log of x minus 1/2 the natural log of open x squared plus 1 close minus the inverse tangent of x minus 1 over 2 open x squared plus 1 close plus big K. Sidebar, in the second and fourth terms we made the mental substitution u equals x squared plus 1. Back to the text. Note, example 8 worked out rather nicely because the coefficient big E turned out to be 0. In general, we might get a term of the form 1 over open x squared plus 1 close. One way to integrate such a term is to make the substitution x equals tangent theta. Another method is to use the formula in exercise 72. Sometimes partial fractions can be avoided when integrating a rational function. For instance, although the integral x squared plus 1 over x open x squared plus 3 close dx could be evaluated by using the method in case 3. It's much easier to observe that if u equals x open x squared plus 3 close equals x cubed plus 3x, then du equals open 3x squared plus 3 close dx, and so the integral of x squared plus 1 over x open x squared plus 3 close dx equals 1 over 3 the natural log of the absolute value of x cubed plus 3x plus big C. Rationalizing substitutions. Some non-rational functions can be changed into rational functions by means of appropriate substitutions. In particular, when an integrand contains an expression of the form the nth root of g of x, then the substitution u equals the nth root of g of x may be effective. Other instances appear in the exercise. Example 9. Evaluate the integral of the square root of x plus 4 over x dx. Solution. Let u equal the square root of x plus 4, then u squared equals x plus 4, so x equals u squared minus 4, and dx equals 2u du. Therefore, the integral of the square root of x plus 4 over x dx equals the integral of u over u squared minus 4, 2u du equals 2. The integral of u squared over u squared minus 4 du equals 2. The integral of open 1 plus 4 over u squared minus 4 close du. We can evaluate this integral either by factoring u squared minus 4 as open u minus 2 close open u plus 2 close and using partial fractions, or by using formula 6 with a equals 2. The integral of the square root of x plus 4 over x dx equals 2 the integral of du plus 8. The integral of du over u squared minus 4 equals 2u plus 8 plus 1 over 2 times 2, the natural log of the absolute value of u minus 2 over u plus 2 plus big C equals 2 the square root of x plus 4 plus 2, the natural log of the absolute value of the square root of x plus 4 minus 2 over the square root of x plus 4 plus 2 plus big C